Okay, so in this video, we are going to talk about scientific notation, what it is, why is it important, and we're also going to use some example problems to better understand the scientific notation. So, what exactly is scientific notation? Well, scientific notation is an abbreviation or a shorthand way to write numbers that are very big and are very small. Now, we have an example here. As you can see, we have the first value of 40 quadrillion and 208 trillion. And we also have the value of 0.00000 and 203 kilometers. Now, look at these numbers. Look at this bunch of digits here. Now, when you are going to include this in your data, you might over-represent it. And you are actually going to make it hard for the readers to read it. Now, imagine along writing this one, or let's say, type it in your computer, and making sure that not any single digit is forgotten. Now, this makes it more difficult. So your scientific notation comes in handy. It will actually convert these massive values into smaller values, but still having the same amount of the value, but still we are going to just shorten the digits or to shorten the numbers. So here is how we convert a very large number or a very small number simple. But before that, we want first to know what is the general format in doing your scientific notation. So basically, in making or in doing the general or the scientific notation, we follow this format, which is actually your x times 10 raised to the y power. Now your x here, it actually indicates the number or the non-zeros with the decimal in a new position. Now, your 10 raised to the y power is actually, it stands for the number of how many times the decimal is moved. Now let's have an example. Okay, let's have an example here. Okay, so just look at these numbers. Look at this bunch of digits right here. You are not going to include all of these digits in your data. Okay, so what we're going to do here is to convert this value into scientific notation. But the first thing we know is that we have to know first where will be the decimal will be placed. Now here in this value, as you can see, we do not have any decimal here. So the first thing to do is to initially place a decimal point on the last value or the last digit of your value. Whenever there is no decimal, but when you have a decimal, you do not have to place a decimal. So here we have a decimal on the last part. Now when you have a decimal on the last digit of your value, you are going to place or you're going to move this decimal into the left direction. Now whenever you move this decimal onto the left direction, you're also going to use or you're also going to count how many digits it will pass by. Now let's try to move the decimal. And together, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, we should stop here. Now, the second thing to do is to, again, know the general format in your scientific notation, which is your x times 10 raised to the power. Now, we all know that your x is actually the non-zeros number with the decimal in a new position. So here in our example, we're going to have 1.0. Why? Because again, your x contains the non-zero with the new decimal point in a new location. But here, how about your 0 here? Now, whenever you do not have a non-zero right after the decimal point, you are going to include at least 1 0 digit. Okay, the next thing to do is to copy this x times 10. Now, what is the next thing to do? What will be our y? Now, we all know that the y is the number of how many times the decimal is moved. Now, we all know that we move the decimal point 13 times, right? So we just basically include, or we are just going to add a 13 as your exponent or as your y. Now, this is actually your answer here. 1.0 times 10 to the 13th power. Now, your exponent here should be positive, because whenever you move a decimal to the left direction, it should always have a positive sign. So here again, you have 1.0 times 10 raised to the 13th power. Let's have another example. What if, let's say, I have a value of 0.000000285. Now, again, the first thing to do is to locate the decimal. Now, we all know that we have a decimal here. Okay? So, no need to initially place a decimal because we already have a decimal here. Now, whenever your decimal is located on the left part of the value, what you're going to do is to move the decimal into the right direction. Now, same thing happens with the first direction. We're going to count all the digits it will pass by. Now, let's try to move the decimal. 1, 2, 3, 4, 5, 6, 7. Okay. So your decimal point here should be here, and we move it 7 times. Now, what we're going to do next is to again have the general format of your scientific notation, with your x times 10 raised to the y power. Now, what will be our x here? Our x here will be your 2.85. Now, again, your decimal point should have at least one non-zero to the left and at least a non-zero numbers to the right. Now, next thing to do is to copy the times 10. Then, now, what will be the value of your y? Now, we all know that we move the decimal point 7 times. So, basically, we're just going to have a 7 here. Now, I want you to remember that whenever you're going to move the decimal to the right direction, you should always have a negative exponent. So, here, we have the scientific notation of 2.85 times 10 raised to the negative 7 power. So that is how you do it. So again, I want you to know that when a decimal point is moved to the right direction, your exponent will be negative. Now, whenever you move a decimal point to the left direction, it should always have a positive exponent. Now, let's try to look for some other examples. Now, let's try to answer this example. First value is we have 48200000000. So, the first thing to do is to know again where is the decimal is. Now, here we do not have any decimal, so the first thing to do is to initially place a decimal here. Now, the next thing to do is to move this decimal into the left direction. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we move the decimal 9 times. And we stop here at 4.82. Okay, the next thing to do is to copy the times 10, and how many times did we move? We move it 9 times, and we move it in the left direction, so it should have a positive exponent. Now let's enter the second one. We have 2530. Now the first thing to know is where is the decimal point is. Here we do not have any decimal also. Now initially write or place your decimal here, and still it is located on the right or on the end part of your value, so your decimal should be moved into the left direction. So 1, 2, and 3. So we should stop here. Now again, write your x value, which is your 2.53 times 10, and we all know that we move it 3 times in the left direction, so it should have a positive direction. Now second value, we have 9,802,000. Now first thing to do, we do not have any decimal here, so initially have your decimal here and move it into the left direction. So move it like 1, 2, 3, 4, 5, 6. Now first thing to do, or the second thing to do, is to include your x value, which is your 9.802, then the times 10, and how many times did we move it? We actually move it 6 times, so 6. It should be positive or negative? Positive, because we move it in the left direction. Now let's look on the fourth example. We have your 0.0025. Now we know here that we already have the decimal point, which is actually located here. So the next thing to do, because the decimal is actually located on the left part of the value, we should move it into the right direction. Now let's try to move it and count how many digits it will pass by. Now 1, 2, 3, 4. Now we should stop here and put your or place your decimal there. So we have the value of x, which is 2.5. Now again, copy the times 10, and how many times did we move the decimal? We actually move it 5 times. Now again, when a decimal is actually moved from right or from left to right, it should have a negative sign. Now let's go on with our last example. Again, we have the decimal right here, and we know when a decimal is actually placed on the left of your value, it should move in the right direction. Now let's try to move it. 1, 2, 3, 4, 5. Okay, again, write the value of x, which is 1.052. Now copy the times 10. Now how many times did we move it? We actually move it 6 times. Should be positive or negative? Negative, because we moved the decimal from left to right. Now let's have another set of example, which will be a different one. Now what if we have 5.8 times 10 raised to the 5th power and 9.13 times 10 raised to the 11th power? Now what we're going to do here is to convert a value from a scientific notation into its original value. Now let's go first with our first example. Now we have the value of 5.8 times 10 raised to the 5th power. Now first thing to do is to include the x value, which is your 5.8. Now next thing to do is to know how many times the decimal is moved. Now we all know the decimal is moved 5 times. Now the next thing to do is to include 0 that is moved from 5 times. So we have 5 zeros. 1, 2, 3, 4, 5. Now I want you also to know that when you have a positive exponent, the direction of the zeros will be from the last part of your non-zero, which is your x8, to the right direction. Okay, and the next thing to do is to, of course, remove your decimal point. And here is actually your answer, which is actually your 5.8 million. Now let's have another example. What if we have 9.8 9.13 times 10 raised to negative 11. Again, the first thing to do is to write the value of your x, which is 9.13. Now, we know that we have a negative 11 exponent here. So it says that the 0 or the decimal is moved 11 times. Now, I want you also to know that whenever there is a negative exponent, the 0 should be written from right to left. Now, let's have your 9.13 here. Now, we have 9.13 and we have 11 zeros written from right to left. Let's try to write it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the next thing to do is, of course, remove the decimal point. So where should be the decimal point located? The decimal point should be located on the last part or on the last digit, which is here. Now, when you do that, you should also include or write another 0 here. So that's it. That will be your final answer, which is your 0.000000000913. Okay, that's it. Thank you for watching.